Welcome to another episode on the Null channel. Now, I know a lot of you guys have been waiting for some more kubeflow videos, and I'm happy to tell you today is not that day. Not that day. Not at all. I'm working on more kubeflow videos. Absolutely working on more kubeflow videos. The problem I've come up with at this point is that really to show off kubeflow pipelines and how you can incorporate them and use them, I need real infrastructure set up. And honestly, here at home, I don't have that real infrastructure in place. And I'm fixing that. I have servers, I just have never set them up in a way where I have this repeatable set infrastructure. I'm always tearing stuff up, tearing it down, and that's going to change. That takes time, and I didn't want to just make no videos for a couple of weeks. So what I decided to do is make a set of videos describing that process and showing how I'm doing, why I'm making the decisions that I'm making, and hopefully sharing some knowledge on some of the stuff that maybe you guys didn't know about. So let's get into it and let's set up this infrastructure in such a way that we can use it for a plethora of projects, not just kubeflow projects.
3, 2, 1, 0.
The Null channel.
So you want to know the requirements of this project. The requirements are running a Kubernetes 118 cluster. It's going to initially start as a single node cluster. If you don't know what that means, it means that we're going to untaint the master node and run worker nodes on the master node. I know, heresy. I have only a single machine and I could a single server that's going to be involved in this. And I could either make it into VMs, which adds extra overhead and pain. And as well as, since I'm going to have GPUs on it, I'm going to then have to share them through I decided not to do that. I'm going to keep it as simple as possible, and I'm only going to add complexity when and where we need complexity. I think that's the first rule of computer science that people overlook. Keep it simple, stupid, or stupid simple, since we're keeping this PG. It's probably G, but keep it simple. Always. Actually, really cool thing about the Raft protocol, Raft algorithm, is one of the things that they went with when designing that algorithm was maintainability. There's actually other algorithms that do kind of the same things. They're just not very maintainable. So keeping it simple is very important. So we're going to keep it simple, and we're only going to add complexity when and if we need it, and you'll be along for the ride, and you'll see the problems we had and why we had to add other layers. So Kubernetes 118, on a bare metal, single node, untainted master. We're going to have a GPU that runs CUDA 9+, and it's going to be exposed to the cluster so it can be used and scheduled as a resource. We're going to use the GPU operator. We need a way to install and manage stuff. I personally love GitOps, so we're going to be using some GitOps. And that way we can actually, and one of the last things that it needs to do is it needs to run my blog from my home. I need it to automatically build the image that is my blog as I pull to GitHub. So what I want it to do is I want to push to GitHub. I want it to pull that change as soon as it builds and passes all the tests, builds the image and deploys it. So in real life, you'd want it to probably deploy to like QA or something. But since this is just my blog and almost literally no one reads my blog, I'm pretty sure no one does. I'm probably not really concerned if it goes down for a day or two. I'm not even sure anybody would notice. If you read my blog and you notice it is down, shoot me an email. All right. So the very first thing that we're going to do is since I took up most of the time today explaining what I was going to do, is we're going to just spend a very short period of time talking about how I'm setting up the network and why I did it the way that I did it. And mostly that was try to protect my internal network. We're also, with this, since I am exposing my home network, we're going to protect ourselves through Cloudflare. So you're going to get to see end to end how you might do a bare metal deployment for a cluster in a data center. We're going to mimic a lot of the things that you would do. Sure, I'm not going to use an enterprise grade NAT or things like that. So no, I'm not running an F5 load balancer. I will mention where we kind of diverge from an enterprise solution. But for a lot of the things, the concepts are very similar to what you would need. We're going to set up everything that you would need, maybe just a little differently than when in a data center. That being said, I'm also going to try to make sure I mention when we differ a little bit from a cloud deployment, because a lot of this would be the same or similar to GCP or Azure or AWS. Or if you're going in my personal favorite, you could stand up a cluster like this in DigitalOcean. So the very first step was to set up networking for it. So what I wanted this to do is I wanted my home network to be isolated from it. So everything that's in my home, even though we use the same internet, to be isolated from it. So I set up its own VLAN. So all of my networking is on Ubiquiti stuff. They don't sponsor me. But I really do like the Ubiquiti stuff. They have a lot of great prosumer stuff. So if you're looking at getting into running some stuff at home, it's a really great entry point that provides you a lot of those features you need if you wanted to do this. So I run Ubiquiti networking in here. And what I did was I set up a VLAN for my Kubernetes cluster and all of the machines that are going to be available to the outside world. And this way, when you set up the routes and traffics in the firewall, you set it up so that incoming traffic can only go to those to that VLAN. And another step on top of that you take is you don't let anything from that VLAN talk to my home VLAN. So it's completely isolated. Now, I then set up a special thing. I wanted my home VLAN to be able to talk to it. So I didn't want to have to go out to the internet back to that, because you could do that, but that seems really painful. And so I'm going to show you how to do that, and we'll get on with it. So as you can see here, I have the LAN. This is the home network. And then I have the Null channel LAN. That's also a corporate. It's on the same port. The USG has 2 ports, LAN 1 and LAN 2. I almost segregate it to the different port. There's a few reasons I didn't. I could get into a further networking on, but it's really a Ubiquiti networking thing with LAN 2 port. I don't like their LAN 2 port on the little USG for the home, but we can get into that. So its subnet is the .2 and it's VLAN 10. And this is my VPN access. So I do have another one. Let's look at this. It's pretty standard. You want it to be on corporate. If it's guest, it's actually not going to be able to have the crosstalk through the VLANs like we wanted. And other than that, really, it's a DHCP server. Manually set the upstreams that I want it to use for name servers, and that's it. All right, so, and then my homeland is there. Let's look at the routing and firewall to see what's going on there. You'll notice here that, let's not worry about the static routes. You'll notice here in the firewall that in LAN in, if these confuse you up here, what LAN in versus LAN out, we can get into that, but at a very, very high level, it's when it's coming into the firewall versus when it's going out of the firewall. If this confuses you, we can do some videos on this, but for the most part, you just want to be focusing on LAN in. It's a very rare occasion that you would want to do anything in LAN out. So first good spot is LAN in. Now, you'll notice this is the priority here. And the priority is in this order here. So All right. We have 3 rules here. First is allow all private IPs. This is just the name. This is not saying what it does, although it should represent what it does. If you notice, it says from the source LAN to the destination of Null, allow all access. So this is not the greatest name. So all we're doing here is saying any communication from LAN to the Null VPN, Null channel VPN, allow access. Then this one is saying all communication from the Null network to the LAN network, block all access. So it doesn't allow anything going the other way. This at its core would work. With just these 2, you could stop and you wouldn't need to do anything more. There would be no communication from the Null to the LAN, my home network. And it would allow communication from the home network to the Null channel network. But there's one catch here. It literally is blocking everything. Everything. That includes the response back. So if you go to make an SSH connection to a machine over there, your communication makes it there, but the response back doesn't. The ping request makes it there, but the response would never make it back. So, and that's what this very last rule here is, allow established sessions. So let's look at it. This is really the only one that has interesting things going on. So what you're saying here is to accept any of these protocols, but the state is accepted, is established and related. So now what we're saying is for all of our LANs, we could have specified from one LAN to another LAN. So, from the Null channel LAN to the LAN, but we're saying for all of them, except an already started communication. So when you send the ping request from here, from the laptop to the server that's running on the different VLAN, it may respond and get through the firewall. So this is really important, or else nothing will work. And it will really seem like you can't actually communicate. It's not true, but that's what it feels like because nothing actually works. You could UDP broadcast if you didn't have that disabled, and that would be about it. So this is how you want to set up your routing and firewalls. We can look at these. These are very easy. So when we're blocking, I said LAN 10, but let's call this block VLAN null to LAN. All right. So all it's doing is we're gonna, on all IPv4 protocols, we're going to reject the difference between reject and drop. So if you're in this and you're wanting to know what the difference, at a very high level, very simplistic level, drop is just gonna pretend it never saw it, and it's just gonna move on. And so if you SSH'd on a dropped one, whatever your timeout is, it's going to sit your command line, your terminal is going to sit there and wait for it, because dropping just going to pretend it didn't get it. And you're going to have to wait for that timeout. Reject is actually going to send back a rejected response. So for me, this is a easy way to see that I've done something wrong in my network, because it's just going to flat out reject it on me. There are pros and cons to each way. Some security people prefer that it just drops it. It pretends that it couldn't route it or things like that. So there are reasons that you could go opt for the drop. I like to know that it wasn't a routing issue and that it's rejected on my end. We can get into the nitty-gritties of security and why you don't tell people that they typed their password wrong. You tell them that they typed their username and password wrong, or one of them didn't match. And that way they can't get any extra information. And that's kind of the idea behind drop versus reject. When you reject something, you are telling them that there was a valid path. You're just not allowed to access it. Whereas if you drop something, they don't know.
All right, so for this next little bit, I want to show you port forwarding. One of the requirements was to access this from the outside world, and to do that, you have to forward the ports, or else the firewall will inherently reject everything. So as you can see here, I've enabled port forwarding on port 80, and I also have that redirect to 443. This IP here, the 192.168.2.10 is actually going to be my load balancer. It does not exist yet. And then for the secure port, everything is the exact same, except that I don't redirect it to 443. All right, so the next thing I want you to notice is as soon as port forwarding is done and you've made those rules in port forwarding, if you go back to Firewall and go to your WAN in, you'll notice that Ubiquiti has already made rules for us to accept this traffic. So you don't have to worry about going in there and making rules to accept incoming traffic. This has already been done for you. So this is our firewall.
This is the networking. That's how I have it set up. And so the next step is going to be setting up the server, installing Kubernetes on it. And so my whole next video is going to be setting up Kubernetes. We're going to install it, get it running, run a few little tests on it just to make sure it's working how we want it. And then all the ancillary things that we need to have a Kubernetes cluster. So when you have one, you'll need an external load balancer. You know, when you're thinking about a security, when you're exposing services through it, you should never expose your control plane to the internet. Since we have a single node, we're actually going to kind of not expose it to the internet, but we're going to have to take some extra precautions to ensure that that is happening that way. And then, yeah, that's what we're going to be doing. So I hope you like this. I hope this whole series of videos is helpful to you, especially because it's going to be helpful to me to bringing you more videos on these subjects, because we're going to have a cluster that's set up, ready to go and run these things. Not only that, you will be able to set up your own cluster similar to mine. And as we do more and more projects, you're going to be able to just clone the repositories as well and have it mirror mine so that you can follow along with a lot of them. And it was just going to work on your infrastructure as well. Now, if you're just getting started, I don't necessarily recommend running Kubernetes in your home. There's ways to have Docker restart a container if that's what you need. If you're just wanting to run a little home server that's going to run some IoT devices, having a Kubernetes cluster is overkill. But if you're going to make a career off of programming apps for Kubernetes, programming for Kubernetes, or maintaining and running Kubernetes, then really I think that it would behoove you to go through these steps to run it at home, because it's a learning experience. You're going to learn the ins and outs. You're going to learn where it fails and how it fails and why it fails. And so if that's you, if you really want to learn and understand orchestration as a whole, then I really highly recommend it. I hope that you found this video helpful, and I'm sorry that your kubeflow videos aren't here yet, but all of this is there to help with that. I hope that you found them helpful. I hope that you found them entertaining. I'm going to try to make them a little bit more fun, a little bit more entertaining than just watching a slideshow, because we've all been there, done that. And I want to thank you guys for your support. You guys have been amazing, and I really do enjoy making videos for you guys. And I hope to bring you more. Don't forget, please subscribe. It tells me that you're liking the content that I make, and it's really encouraging to me when you do. So please subscribe if you liked it. If you didn't like this video and you're still here for some reason, you hated the video and you hated it so much that you stuck around so that you'd have more points of why you dislike this video or me, go ahead and hit the subscribe button, stick around, and see if these videos get any better for science.